Hi class. Google Meet didn't work today. Live stream didn't work, so I'm just going to pre-record what I was planning to do. It's not a lot. I'm just going to explain to you how electrons are distributed in the atom as far as grade 10s are supposed to know. And then I'll show you what you need to study for on the test we're going to have Thursday or Friday, depending on when you come in. Sorry, next week you're coming in, so that's when we'll have the test on the periodic table. So in the meantime, you're going to memorize a few things. I'm going to take you through everything you need to know, and then I'll post other videos that show you all the things you need to memorize. Okay, so the first thing we're going to look at is how atoms distribute the electrons. So whenever you have an atom, it's going to have protons, it's going to have electrons to balance off the charge of the protons. For example, if you look at helium, helium has 2 protons, and you always write the atomic number on the bottom left of the symbol. So that 2 next to the helium signifies that there are 2 protons in the nucleus of helium, which means the nucleus has a +2 charge. So a neutral helium atom is going to have an equal number of minus charge in the form of electrons. So it's going to have 2 electrons, and up to 20 electrons. You can show it with this simplified orbital scheme. So there's 4 different levels of energy, and the electrons go to the level that's closest to the atom when they go in, and you use up all the levels until you've used up all the atoms. So in the case of helium, there's only 2 electrons to worry about. So you fill in the first level because its maximum amount of electrons that it can hold is 2. The second level can hold 8, the third level can hold 8, and the fourth level can hold 2 again. In the case of lithium with a positive charge, you'll notice because lithium has 3 protons, and in this case has a positive charge, it's missing 1 electron. So it has a +1 charge. So that's how you portray it. You show that there's only 2 electrons in the orbit that is closest to the lithium atom. If it was a neutral lithium atom, then you would throw in that one as well, and then you would see the 3 electrons balancing off the 3 protons so that you'd have no charge. There's 1 in that orbital. If you go to nitrogen, which has 7 protons, it has to have 7 electrons as well to be electrically neutral, so you put 2 in the first orbital and then 5 in the second one. Calcium has 20 protons, and therefore it's going to have 20 electrons if it's neutral, so you fill each one, 2, 8, 8, 2. And calcium with a +2 charge is missing 2 electrons, so the last orbital has no electrons in it, it goes 2, 8, 8. So you should also know in the test, and I will eventually give you something that looks like this. I'll give you a photocopy of what I expect you to memorize on the periodic table test. And I have an exemplar here. What you're expected to write in a perfect test when you do come in next week is going to be something like this. So you'll go from a blank sheet to having that all filled out. You're not going to do this part though. This is for grade 11, so you can ignore that little bottom part. These are the questions written on the back and how much each one is worth. So we'll go through that quickly. One of the things you're going to have to answer is a key for the atom. What information does each position around the atom contain? So position 1 is the mass number, and it is the total of protons plus neutrons. Position 2 here is where you put the charge, top right. So if the atom has a charge, that's where you put it. The third position on the bottom left is the atomic number, and it tells you how many protons the atom has, and it also basically decides the name of the element, because the number of protons decides what the identity of the element is. If you have 6 protons, your name is carbon, and so on. And then finally, the fourth position tells you how many of the atom are present. So for example, if you have H2O, the 2 applies to the hydrogen. It's telling you that you have 2 hydrogens and 1 oxygen, and you don't bother writing the 1. Some of the other questions that are on this test, obviously you have to memorize all those elements up to radon. So all these groups 1, 2, 13 to 18, and then the first 2 strips of the transition elements. So memorize all those element symbols in the right place. I've shown you all the tricks. I'll post the video on how to memorize the periodic table as well, so you'll find it easy if you follow the instructions. You can develop your own tricks too. It doesn't have to be the way I do it. I just give you ideas. Here are the questions I asked on this particular test, which yours is going to resemble very much. The first question was, write your name. Believe it or not, some kids don't write their names when they hand in the paper, and then I have to do detective work to find out who it is. So I'm going to give you 5 marks just for writing your name. Number 2 is symbols for groups 1, 2, 3, 13 to 18, and all of periods 4 and 5, as I have illustrated here. And I'll post a picture of this so you can refer to it. All group and period numbers. So obviously across the top it goes 1 through 18, and on the side it goes through 1 through 7, and then it goes 6, 7. So do that. Then that's 25 marks just for getting all the group numbers and all the period numbers right. So easy marks. Then I might ask you to fill in a shell like this to give you the configuration of an atom up to as big as calcium, and it might have a charge in it. So keep in mind that if it has fewer electrons or more electrons, depending on the way it has a charge. And let me give you an example where you might have extra electrons. If you, for example, take nitrogen, and nitrogen can be nitride, where it has a -3 charge, then it has extra 3 electrons. So that would fill up this shell, and this shell would end up having 8. So there's 10 electrons in nitrogen with a -3 charge, because since there's only 7 protons, how are you going to get a -3 charge? By having 10 electrons. And that's how, that would be the configuration of the nitride anion. You should be able to write all the atomic numbers in every atom. Obviously, hydrogen is 1, and then helium is 2, and then you go across like a paragraph. If you don't want to write all those numbers, then just memorize these 4, where that squiggly line should be, which I didn't draw yet. Here, I'll draw it in right now. There's your squiggly line. And why do they write that squiggly line here and here? It's because this part of the periodic table was all cut out from this spot, and that's why the numbers jump as much as they do. They jump from 57 to 72 and from 89 to 104. All the missing numbers are in these 2 strips, which they just cut out to make the table fit on a regular sheet of paper. Finally, all the metalloids are going to be identified with a star, like I did here. See, I put a little star on each metalloid, and they're all the ones sitting on the step, and these 2 as well. The diatomic elements are going to have a check mark. There they are. It looks like a pattern of a number 7. Or you can memorize it by saying Nofkel Briat, and don't forget hydrogen. Hydrogen is also diatomic, so I put a check mark in there. And then one conversion factor, like convert, for example, 10 feet squared into nanometers squared. I'll show you how to do that one. And that'll be it for today. And I hope you study, and I hope you watch the videos. Don't just sit at home relaxing all the time, because you won't learn anything that way. I know this pandemic has created a lot of excuses for everyone, but don't accept excuses from yourself. So 10 feet all squared basically means once you distribute that squared symbol, that you have 100 feet squared. Because remember, the squared, when you have the bracket around there, is distributed both to the number and to the unit. Then we're going to convert to inches, 12 inches per 1 foot, raise that to the power of 2, times 2.54 centimeters per 1 inch, raise that to the power of 2, times 1 meter per 100 centimeters, raise that to a power of 2, because remember we're dealing with area. And finally, there are 10 to the 9, there's a billion nanometers per every meter. Raise that to the power of 2. The answer you're going to get is 9.290304 times 10 to the power of 18. If you ask Siri, she'll tell you the same thing. Okay, that's enough for today. I'm not posting a lot, but I want you to learn that little bit that I put, so that I don't need to post a lot because I'm finding people aren't really looking at the stuff very carefully. So learn this little bit really well. Maybe a little feedback wouldn't hurt, and tomorrow we'll follow up. I'll see you tomorrow.